Hello everyone. In this video, I'm going to make an chuck backplate for my Southbound 9. I'm going to mount a 3-inch chuck in my Southbound 9 lathe to do some watchmaking work. In my next project, I'm going to make my own watch case and this chuck will come very handy. Let's get started. I got this 2-inch stock from my scrap bin. I don't know what steel it is and most likely it's a mild steel. For this project, preferably a stainless or a stress-proof steel would have been better. But for what I'm going to use this chuck to take light cuts for my watch parts, so there should be plenty. I'm facing off the stock so that we can get concentricity. I'm checking the trueness of my chuck by using a dial indicator. It's spot on. Southbound 9 lathe has a threaded spindle with a dimension of 1.5 into 8 threads per inch. We will start drilling, boring and threading this round stock and convert this into a backplate for my Southbound 9 lathe. Stock has been spot drilled. Now it is ready for drilling. I'm applying some cutting oil and I'm using an 1/2 inch drill bit. And I wanted to drill it to a depth of 1 inch as I want the thread to be around 1 inch in wall length. I have enlarged the hole by using multiple drill bill sizes. Now I'm using an 1 inch drill. This is my last drill operation in this chuck. After this I'll be using my boring bar to bore the inner diameter to the dimensions what we need to thread 1/3 per inch for my south band spindle. Alright, we completed our drilling operation. Right now we are around 1 inch. The drill bits are not that accurate, but it should be close enough. Now we need to bore this to the actual dimension. The actual dimension for the inner diameter for an 1.5 into 8 thread is 1.3647. I'll be using my carbide boring bar to bore it to the dimension. Alright, now we can start focusing on the boring operation. I'm taking very light passes here to true the inner diameter. The drilling operation we performed previously will not be accurate. It should be close enough to 1 inch, but this spring path should bring the inner diameter true. And the target we are shooting for the threading operation is 1.3647. That should be the inner diameter of the stock. So I'll be taking around 300 thousandths using this boring bar, and I'll be making some aggressive cuts here. And after that, I will switch my boring bar to a fine boring bar where I'll be boring the remaining 64 thousandths to get to a very accurate dimension. After boring for 5 minutes or so, I was able to enlarge the stock to the dimension of 1 inch and 300 thousandths. Now I'm using my fine boring bar to dress the shoulder at the end. So typically when you bore using a positive thread stop, not a thread stop, basically a positive stop, you don't get a good shoulder. So I'm taking very light passes here with my fine boring bar to get a good shoulder at the end. After finishing the shoulder now, I'm making my way to finish the inner diameter. I need to remove around 64 thousandths to close on the dimensions. And this is my final pass. And I'm cleaning up the bore hole. Now checking with my inside micrometer, see how far I am. We are spot on the dimension of 1.3647 inches for the inner diameter. This completes the boring operation. Now I'm going to set up the lathe for the threading operation, and I'll be using a left-handed threading bar. I usually use a right-handed threading bar, but what I learned is that if you use a left-handed threading bar, it makes the threading operation much easier, and also it gives us a better finish. And you don't have the risk of crashing the threading tool with your lathe because you will be feeding from left to the right by running the lathe in the reverse. Before we start the threading operation, I would like to add a chamfer with the chuck. This helps us to insert and remove the chuck easily from the spindle nose. And the depth of the chamfer should be same as the double depth. For an 8 thread per inch, it should be 162,000. Now I'm using my internal grooving tool to create an internal groove, and the depth should be the same as the double depth. It can be a little bit more as well, should not really matter. The beauty of using a left-handed threading bar is you don't need to land or disengage the half nut lever in the exact position in the groove. Rather, you can just feed in from left to right and bring back the tool into the groove manually using the hand wheel, and then we can feed in using the compound. Alright, so finally we are ready to cut threads, and I've set up the machine to cut 8 thread per inch, and I've set the compound at 29 degrees, which is a standard angle for cutting V-shaped thread. I'm using a left-handed threading bar. For left-handed threading bar, you need to run the lathe in reverse, and if you're using a lathe like mine, which has threaded spindle nose, you need to take very light cuts. If you take deeper cuts, you might end up in unscrewing the chuck, and which might land in your wave, which will be a disaster. I'm taking my first cut by feeding in the compound by 1/1000. Now I'm using my thread gauge to see the correct thread pitch I'm cutting or not, and in this case, yes, I'm cutting 8 thread per inch. Now I can go ahead and further feed in the compound with multiple passes. So typically it takes around 50 to 20 passes for me to get to a place where it looks like a thread, and then we can start measuring with the thread gauge or with the test piece I created, which mimics my spindle nose, to see how well it fits, and then we can take the stock out of the chuck and test it with the real lathe. The beauty of this method is, since you are feeding from left to right, you don't need to exactly disengage your half nut lever at the exact position of the groove. Rather, you can just engage your half nut lever and allow the threading tool to move from left to right, and after it exits the chuck, you can just back it off and bring it back to the groove and start feeding through your compound for your next cut. This makes the threading operation very simple and very safe. We are almost there, and I'm using a test space I made to see how far I am from the thread. It's getting in there, it's a little tight, and you see that one side thread and it's not getting in there, so we may need another pass or two. I'm unscrewing the test piece. Testing the thread depth with the thread gauge. Looks like I'm not very far. Maybe one more pass should do the trick. Feeding in. Waiting for my thread dial to come to an line. Engaging my half nut lever. This time the test piece screws in very, very smooth. You can see that there, and I see a play, and the play what we got is perfect. This will be a very good fit for my chuck. As the next step, we need to open up this threaded chuck to an insert diameter of 1.5095. The original boss on the south bend 9 chuck is 1.509 to have a very snug fit. I'm just opening up this to 1.5095. This is a very important step. The tighter the fit, you get a better run out. So I'm taking my time here to open up the chuck to mate with the boss and the original south bend spindle. On the depth on the original chucks in south bend, it looks like they have opened up for 200 thous on the depth of the boss, but I'm just going 225 here. And I'm taking multiple passes here, and I'm doing constant measurement to make sure that I'm not overshooting it. I finished boring the thread, and we are in 1.5095. This should be a snug fit. Let me go to my southbound 9 lathe and try to see. Now the moment of truth to see whether the chuck fits or not. It goes very smoothly. I really like the way it turned out. And the groove or the boss we opened up exactly matched in the boss and the southbound chuck. This should give me great repeatability. Now I'm going to face it off and turn this and create a boss here to attach my 3-inch chuck. We are almost there. I'm taking some light cuts in the chuck. You can see that it's very rusty. It came from my scrap bin. And I'm going to do multiple passes to bring the shine from the metal. And this will make the chuck concentric with the nose spindle. Now making a chamfer at the end so that it will be easy for me to handle the chuck without cutting my fingers. Now we can face it off. Here is the finished product. I turned a boss for my chuck and the threads. Boss has been turned around 30 millimeter, which exactly fits my chuck, and it's very snug fit. It's very tight. It came out very well. Now we can use a punch to center mark the screws, which will be holding the chuck on the back plate, and I'm using an iron hammer to mark it out. So this completes this project, and as you see, it is turning very true. I'm using a test piece to see how well it holds and cuts. Thanks for watching. If you like my videos, please like and subscribe. Happy machining. See you next time.